We've been talking about making new data types, the sort of built-in data types, and then using a union type to combine these to get a new type, or a struct to get a new type, a compound type. And then between union types and compound types, we came across this interesting combination when we made our data definition for a list, seeing that by having a self-reference, we can actually make this linear data type. Even if we don't have arrays built into our language or lists built in, we can make a list. And you know what? We can process a list without a loop. We don't need a for loop in our language to go ahead and process the list. Why? We follow the template that follows from that definition of the data. And since we had a self-referential data definition for a list, we're going to have code that's going to be recursive in that same place. And boom, we get that without needing extra things in our language. So that's kind of interesting. Let's see another example of a data definition like that, one that will let us do linear processing without a list. And this is going to be just regular old numbers. Natural numbers. And here's a little thought experiment. Imagine if you had a programming language, but it didn't have numbers built in. Well, gosh, you're like, that's impossible. How could you do that? Well, earlier you may have said, hey, if there's no arrays or lists built in and no loop construct, you couldn't, do anything. Well, we saw that we could. So let's go ahead and do this. And by the way, if you go and ask a math major, what is a number, a natural number, this is the answer they're going to give you. If you ask most people, they'll say a natural number, it's like 0, 1, 2, 3, dot, dot, dot. And you're like, well, dot, 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 how do I make code out of that? How do I represent that in my program? So the mathematician says, okay, natural number is either some special unique value that we'll use to represent 0, okay? And we're going to go ahead and call that tick sunya, okay? I just made up some symbol. You can use whatever you want. I'll go ahead and use tick sunya to mean, hey, that's going to be my representation of 0 in my weird head program. And then I'm going to go ahead and have a structure called the successor structure. And if you give me a natural number and make a successor out of it, that itself will be a natural number. And again, this is how mathematicians define the natural numbers. So you're either 0 or a successor of some natural number. Not a successor of 0, not a successor of a positive number, a successor of any natural number, including could be 0, could be something else. So I'll go ahead and call this data definition natch, just to make sure that we're not using any built-in type already. So a natch is either tick sunya or make successor of a natch. So I guess we need a define struct for that. So define struct successor. What fields should we have? There's only going to be one field of type natch. And I'm going to call that field pred for predecessor. Maybe pre for previous. Okay, great. So that's my data definition. Step 1 of our designers, make a data definition. Step 2, what was it again? Remind me? You can pause and look it up if you want. Right, some examples of the data. Can you give me some examples of natches? And remember, they have to come from this definition. You're not allowed to say 17. That doesn't follow this definition. What does follow the definition? Well, it has to be tick sunya. Oh, tick sunya. That's a natch by our definition, and we're going to use it to represent 0. How would we represent 1 in our crazy definition? Well, I've already used tick sunya. I only have 2 ways I can be a natch, so I guess I'll have to say make successor of some other natch. Gosh, oh, the only natch I have is up there on the line before me, tick sunya. Okay, this is going to be my representation of 1. Okay. And I'm going to go now, scroll up. I have some that's written down here. Okay. So we have some examples of the data. Can you make me another example of a natch? Okay, make successor of, and I'm just going to copy and paste the thing I had previously. And yeah, we agreed that that was a natch, and so make successor of any natch is itself another natch. Okay, weird, but not wrong. And then, so this will be this is how I'm going to represent in2 in my weird idea of, hey, I'm not going to use numbers, but I still want to work with numbers. Okay, so how about 3? Well, you get the idea. Make successor of, copy paste another natch. Okay. So that goes ahead and gives us several examples of our data. We can use these as test cases later on. By the way, it's a little bit hard. If I want to talk about 7, it's kind of annoying to say, oh, make successor of, make successor of, make successor of, make successor of, make successor of Sunya. That is how I'm representing 7, but just tedious to say. So I'm just going to do a few defines, do some names to these. I'll go ahead and define uno to be, and let's see if I can put this, make successor of Sunya. Okay. Spell define correctly, great. And great, so now I'm just going to be able to say uno, it's the same thing, I'm just giving a name to it. Okay, and how about dos? Dos will be, I guess, make successor of Sunya. Of course, I could just say make successor of uno at this point, since I now have the name uno. Okay. In fact, I'll go ahead and, for test cases, it might be handy, I'll go ahead and define some other variables called tres, cuatro, cinco, seis, and siete. Okay. Sounds. In fact, for completeness, I'll go ahead and define one called cero. So these are my variables that stand for the underlying real structure. And of course, we can go down here and just get these worked in. Get that to compile. That's ahead in the file. Don't look at that. Ignore it as if you've never seen it before. Sorry, I hadn't had that ready. Okay. Okay. So these are our built-in names. And if I just say something like, yeah, what is trace, then it comes out with make successor, make successor, make successor of Sunya. So, okay, great. Those are our examples of the data, a bunch of examples of the data, actually, and given names will be helpful for test cases. Just for fun, you don't need to really do this, but I'm going to add some more predicates. I'm going to add a little function called is0, takes in anything and says, hey, is this weird? Is this the natch that represents 0? Which is just argue the symbol tick Sunya. So define is0, great. Remember that, by the way, when we did the define struct of the successor structure, we got another function called successor. So, okay. If I wanted to, by the way, I could go ahead and define a function, hey, are you a natural number? And remember our data definition of natural number? Our natural number is either 0 or the successor of something else. So yeah, I could go ahead and actually have this as code, define natch of x to be either, to be or, is 0 of x, and successor of x. So if I really wanted to, I could say, and so is successor of x, and what do I need to say about the field inside of that successor? How do I pull out the field inside that successor? If x is a successor structure, then that's the getter. And I sort of said, hey, this has to be of what type? This has to be a natch. So if you want to, you don't need to, we can define our own predicate, natch, that exactly matches our data definition. And as this. I'm not going to use that again, but it's certainly there. Okay, so what is our template for any function handling a match? Let's go ahead, and again, I'm going to split the window so we can view the split. So view the data definition and write with it. Did I manage to select that correctly? Okay, good. So we have our little 3-line data definition. Go ahead and pause the video and write the template for any function processing a match. You've done this a bunch before. You should be able to do it. Should be wrote at this point. Okay, you're done. You've done and unpaused. Great. Yeah. So func for natch. Give me a nat. Okay. And I'm going to go ahead and have a cond. I'm going to really say, wow, when I'm running Camtasia and Dr. Rack at the same time, things really slow down. Okay. Gosh, do I have a look at my data definition? Am I in the first case of my union type or the second case of my union type? And that's just a union with 2 variants, right? So, okay. Go ahead and ask, is 0 of a net? If so, I'll have some answer. I don't know quite what, so I'll just say ... Otherwise, I could say successor. I could just say else, but successor of nat. Okay. And now here's again where we've added some things here. If we have a successor, then we're a structure. So what do we do in the template? We're going to pull out, inside this branch of the cond, we're going to pull out the fields from that structure. And there's only one in this case. Okay. So this is our template, and I guess I'll put a ... saying we need to use that one field and somehow, call some function on it and get an answer. What type is that field? Oh, looking back up at my data definition, it's a natch. What function might I be calling on a natch? Wait a minute, let's put in that natural recursion. Func for natch is exactly the sort of thing that wants to be given one of these. 9 times out of 10, include the natural recursive call. Again, I say it's the natural recursive call because I'm recurring, my code is recurring in exactly the same place where my data definition was self-referential. Okay, great. So this gives me my data definition. Now we're ready to go and start writing my template. This gives me enough that I can go and start writing some functions that deal with natural numbers. Except I'll take a little pause. Actually, we'll break here and continue this in the next video. See ya.